In this video, we're going to talk about motion diagrams. Motion diagrams are like a series of pictures taken at regular time intervals. So for instance, the car shown here was at one point, and then maybe a second later the car was here, and a second after that the car was here. And in this diagram, since the car was traveling equal distances in between each time period, whatever the time period is, since it was traveling the same distance each time period, then the velocity is constant. Okay? And so it's just like taking a picture every second or every tenth of a second, whatever the case may be, and laying all those pictures together. In this case, we are defining the right to be the positive direction. That's for all 6 cases that we're going to go through. And so here the car is moving to the right, so its velocity is positive. And since it has a constant velocity, the acceleration is 0. Remember that acceleration is equal to delta v over delta t. Change in velocity over time. Here the velocity doesn't change, so the acceleration is 0. Next up, we have an object that is moving at an increasing speed to the right. And we don't have to be fancy. For these motion diagrams, usually we just draw dots. So if the motion is increasing, if the car or whatever the object is speeding up, then that means the spacing between the dots is increasing. So in this case, since the object is moving to the right, the velocity is positive, and then we can look at the acceleration. Let's just pick a point. We'll say the initial point, the velocity was, say, 1 meter per second. And then at this final point, the velocity was, I don't know, let's go with 9 meters per second. And then how much time elapsed? Well, let's say that there's 1 second between each dot. So that's 1, 2, 3, 4 seconds that passed. There are 5 dots there, but only 4 seconds elapsed. So the acceleration is equal to 9 meters per second minus 1 meter per second over 4 seconds. And so that is going to be a positive number. So we can see that the acceleration is positive. And if you want a number, there's 8. And so that's 8 divided by 4. So that's 2 meters per second, or we can also say that is meters per second squared. Let's go on to case 3. So this object is moving at a decreasing speed to the right. So at first, moving quickly, but then moving slower and slower. And again, we can make up some numbers to go with this, and we can just pick any numbers that we want. Let's say it was going at 12 meters per second, and then later on was going at, and that should be v naught x, that's the beginning velocity, and the later velocity, we can pick almost anything we want. It just has to be less than 12 because we know it's a decreasing speed, and that's how we drew our dot diagram. Covered a lot of ground at first, then covered less ground, even less, even less. So just some number less than 12. It does have to be a positive number since we have our object moving to the right. And so now we can calculate our acceleration to figure out if it's positive or negative. So the velocity is positive because the object's moving to the right, but what about acceleration? Acceleration is equal to final minus initial. Okay, whenever you see that delta, you always want to do final minus initial of whatever, whether it's momentum, velocity, energy, any of those quantities. So 8 meters per second minus 12 meters per second divided by, let's see, 1, 2, 3, 4 intervals again. That's 4 seconds. So this would be negative 4 divided by 4, or negative 1 meter per second squared. So here we have a negative acceleration. You could say that's a deceleration. All right, next one. Draw a motion diagram for something that's increasing speed to the left. So it starts here. So that's our v naught x equals some number. let's just say it's 2 meters per second. Going slowly, a little faster, a little faster, a little faster. All right. And then here we'll say that this velocity here is, say, oh, and I made a mistake. I said this was 2 meters per second, but it needs to be negative 2 meters per second. And then this is some negative number, but it's a larger magnitude, so say negative 12 meters per second. So here the velocity is negative, but what about the acceleration? Well, let's make sure. You might be thinking it's positive because the object's speeding up, but let's just double check. So final velocity, minus 12 meters per second, minus the initial, divided by the time, and there's 1, 2, 3, 4, 5 time intervals this time. So negative 12 minus negative 2 is the same as negative 12 plus 2, or negative 10. Negative 10 divided by 5 is negative 2. Sorry about that. Negative 2 meters per second squared. So in fact here, the acceleration is negative. The object is speeding up, and yet the acceleration is negative. Let's look at 2 more examples. Here, the object is decreasing speed to the left. So our initial velocity here, v naught x, some negative number, say negative 20 meters per second, going really fast, a little slower, a little slower, a little slower. And then we'll say that this is a vx of negative 4 meters per second at this dot right there. All right, so the velocity is negative. What about acceleration? You think, oh, it's slowing down, the acceleration must be negative. But we'll check that. The final velocity, negative 4 meters per second, minus the initial velocity, which is negative 20 meters per second. And then we divide by 1, 2, 3, 4 seconds there. So negative 4 plus 20 is 16. 16 divided by 4 is positive 4 meters per second squared. So that is a positive acceleration, even though the object is slowing down. So now we want to just do one final case. This is an easy one. Moving to the left at a constant speed. And we know that the velocity is negative. And since it's a constant velocity, that's 0. But now we want to make some conclusions about speeding up and slowing down. So speeding up happens when velocity and acceleration are in the same direction. We could say the same sign. And that happened in, let's see, case 4, we had speeding up. We had negative and negative. And in case number 2, positive and positive. Okay, and then we want to look at slowing down. Okay, we'll put in the case numbers. Slowing down happens when the velocity and acceleration are in opposite directions or opposite signs. And when did that happen? Well, here we've got a negative and a positive, so case 5 is an example of that. And then also case 3, we have a positive and a negative, and that was one where it was slowing down. So 3 and 5. Okay. So this is one of the most important things from this module, is that speeding up happens when velocity and acceleration are in the same direction. It's not the sign of acceleration that matters. It's whether the sign of acceleration matches the sign of velocity. If it does, the object is speeding up. If those objects have opposite signs, then the object is slowing down.